Okay, so we're going to start 1.3, which is algebraic expressions. However, we are not going to discuss most of it, which is because there are simple factors, but I will discuss the ones that we don't see often. Okay, so part of it. All right. So, oh, I have to share my desktop first. Ooh, let me close this, because otherwise it's not going to get recorded. So this is my desktop. Okay, so now I am ready. Yesterday I forgot to press record until 20 minutes, not your class, a different class. So maybe when recording plays, they're going to see blank page. I have my phone, but so you guys have to remind me, did you record it? And then this one is, you see this yellow one? This means I'm sharing the desktop. So if you don't see this while I'm on Windows Journal, you please let me know, okay? Because you probably wouldn't see the desktop either when I record it. Okay, so 1.3 is algebraic expressions. So as I said here, we have multiplying monomials, multiplying polynomials. There is a special product formula. So let's just talk about that first. So A, there are some special products that is handy most of the time. So special product formula. And when you use it instead of foil, make it lock, it is helpful. All right. So the first special product, which is very helpful, is A plus B times A minus B. Okay. What's so special about it? Why is this special? What is A plus B times A minus B? Yes, A squared minus B squared. So even though we can do FOIL, we don't want to do FOIL. We want to remember this is a special product. The outer and the inner cancel, so we have first is A times A, last is B times negative B. That's why this is A squared minus B squared. All right, now what about the second one? A plus B squared. I know you could do FOIL, but let's use the special product. So what we do is we square the first term, okay, and square the last term, and there is 2 times AB. I think you remember this, don't you? Okay. So what about if I have A minus B squared? Well, it's the exact same thing. We square the first term, A squared, and we square the last term. What happens to the middle? Negative what? 2AB. Yes. So the middle, the outer and inner is the same, and they're negative. That's why you have minus 2AB. Now, the last one, this is probably new, but it will come in handy sometimes. A plus B cubed and A minus B cubed. So what is A plus B cubed?
A plus B times...
you're talking about these, I think,
oh, yeah.
right? Yeah, so you're trying to pattern these. So this is something else. So this one, actually, later on, when we use binomial theorem, we will see this again. But for now, you could memorize it. So it's A cubed plus 3A squared B plus 3B squared plus B cubed. So it starts with A cubed, then the power of A goes down. So it's A squared and you have B. And then, oh, I'm missing something. This is supposed to be what? 3ab squared. Yes. Plus b cubed. So you see the pattern? What's the pattern here? A cubed followed by a squared followed by a, and then a to the 0 is 1. How about the b? You start with b to the 0 with 1, and then b squared, and b cubed. And the coefficient is 3 and 3 in the middle. 1, 3, 3, 1. Okay, so when we get to binomial theorem in chapter 11, you'll see this again. What about a minus b cubed? It's the same thing. It's just that the signs alternate. So it is a cubed minus 3a squared b plus 3ab squared minus b cubed. So it's just the signs, they alternate. Plus, minus, plus, minus. All right. Okay, and now can you do these two problems? So evaluate or simplify. Okay, so number 1. What about 5x plus 2 squared? And what about if I have, oh, let me give some space. What about if I have x squared minus 3y cubed? All right. So I know for number 1, we could do FOIL, right? But we want to use the special product property as much as possible. Okay? So in this case, what is your A and what is your B? So 5x is A, that's right. 2 is B, okay. All right, so what was the formula? A squared plus 2ab plus b squared. All right, so tell me, what is a squared? 25x squared. Right? Or you could do this first. So you could say, oh, this is 5x squared, okay, plus 2ab, so 2 times 5x times 2, plus b squared, which is 2 squared. So I'm just substituting my a and b to my formula. A squared plus 2ab plus b squared, which is what? 25x squared plus 20x plus 4. Finish. Or if you know how to get 25x squared, you don't have to write the middle, this portion here, you don't have to write. Some of you are fast. All right. If you want to write it, then you can. If not, that's fine too. Okay. What about x squared minus 3y cubed? So which one's your A, which one's your B? A and B. So which formula am I using? Yes. So the signs alternate. Right? Okay, so do we want to write the cube or do we want to cube it directly? I could write it. What will it be? A cube. What is A cube? X squared cube. Or you can write x to the 6. It doesn't matter. Right? Minus 3ab. What is 3ab? 3 times x squared times 3y. Okay. Plus 3a squared b. Yes. 3 times x squared 3y. What's the next one? 3ab squared. What is ab squared? X squared 3y squared. And what's the last? Oh, minus. Minus b cubed. What is minus b cubed? 3y cubed. All right. Okay. So what is this? you can't use your phone here, right? You want to put it on my desk? Okay. You can put it on my desk. No, you have to put it on my desk for the time being. All right. So let's do this. So this is x to the 6. What about this? Minus 9 x to the 4 y plus 3. This is 3 squared, so it will be 27 x squared y squared, and the last one minus 27 y cubed. All right. Okay. So should we do another one? The cube? Okay, so let's do another one. What about if you have 2x squared plus 3y cubed. Okay. So can you work on these? All right. So what is your A in this case? Right. What is your B? 3y cubed. Okay, so what was the formula again? You can write it here if you want. A cubed plus 3a squared b plus 3ab squared plus b cubed. So you can write it here if you like. Yeah. So maybe you'll remember once you write it often. What is a cubed? To x squared cubed. So if you want, you could write directly 8x to the 6, right? Okay. Plus 3 times a squared b. What is a squared b? Well, let's just write it. 2x squared squared 3y cubed. Oh, that's it. Is it? Plus 3ab squared. So a is 2x squared. B squared is 3y cubed squared. All right. So this is 3. And the last one is b cubed. What is b cubed? 3y cubed. All right. Are we okay so far? Okay. Now the next one is we will simplify. So what would this be? 8x to the 6. All right. Plus, so 2 squared. 2 squared is 4. 4 times 9, 36. X to the 4th y cubed. Plus, this is 54. So let's see, we have 2 squared, which is 4. 4 times, is it 54? Oh no, the 2 I didn't square, right? So 27, so 9 times 6, 54, you're right. 54 x squared y 6. And the last one? 27 y to the 9. All right. Yes. What's your name?
Andy,
Andy. Yes, Andy.
why is it 3y spectrum? And why is it cubed?
Oh, your original, your B is 3y cubed. Yes. So those are just your B. Yeah. Good question. Yes. Are we okay? So far? Yeah, we're good. So move on. Okay, so if I were you, when I study, well, number one is we've seen before, or maybe, or if not, then but my emphasis will be number 2 and 3. Yeah. All right. Now next, factoring. So B is factoring. Okay, guys, then if you come late, you can just take picture and then finish later. Yeah. So B, factoring. All right. Okay. Now we factor out common factor first, right? We know that, don't we? Okay. What is not common is this one. Factoring ax squared plus bx plus c when a is not 1 or a is not negative 1. So, what happens if a is not 1 and a is not negative 1? So what do you do? So for example, if you want to factor this. So for example, factor number 1, 6x squared plus 7x minus 5. I know you could factor out something like this, right? Minus 5x plus 4. Can you factor out x squared minus 5x plus 4? What is x squared minus 5x plus 4? Yes, so x minus 4, x minus 1. So this one is, you know very well, don't you? So that's why I don't review. What about if I have x squared minus minus x minus 20? What is x squared minus x minus 20? X minus 5? X plus 4? Yes. So this one is usual. So I'm not discussing it. What about if I have 6x squared plus 7x minus 5? Okay. And what about if we have something like 8x squared minus 14x minus 15? Or, okay, let's just work on these first. Yeah. What do you usually do? How do you factor out 6x squared plus 7x minus 5? Do you use trial and error or what? What do you usually do? What happened? I'm sorry, who's saying something? I can't. Factors of 6, so what would you do? Oh, so you're doing trial and error, like this, right? 2 and 3, or 6 and 1? Oh, okay. Yeah, that works. Yeah. So if you could find the numbers here, it will work. Yeah. But sometimes after we try 3 times, then I get frustrated, or we get frustrated sometimes. So I have what is called the AC method, and you don't have to do trial and error. Yeah. So if it is factorable, then we could factor it using the AC method. So I'm going to write here. I don't know if you've seen it before. So but try this. Unless you're really sure, you could do the trial and error method. Or the other one is grouping, but it's longer. This is the short version of grouping. So if I use the AC method, so I'm going to write here. So AC method for factoring ax squared plus bx plus c when a is not equal to 1 or a is not equal to negative 1. Because if it is negative 1, we could factor out the negative. So number 1 is set up. So we will set it up as ax divided by a. That's how we set it up. All right. So now I'm looking back at my problem. How do I set up if I want to use the AC method here? What's your A? So 6x divided by 6. Okay? Okay. So to find two numbers such that their product is AC and their sum is B. Okay. So now in this case, my product will be what? I could use something like this, but probably don't need to. You want me to use the cross or no? Or it doesn't matter? So product is equal to, what is the product? AC. What is AC here? 6 times negative 5. So this is your A. 6, this is your C. So 6 times negative 5, which is negative 30. So product is AC. Sum is B. What is B here? 7. Okay. So product is AC. So this is your A, this is your C. So what are the two numbers? Find the two numbers. 10 and 3. So let's adjust the sign. Negative 3. All right. So if I multiply, the product is negative 30. If I add, this is 7. Right? So now I'm going to put plus 10 minus 3. All right. I'm almost done. I'm not done. I have to simplify with the denominator. Yeah. So what would I do? How do I divide this by 6? I don't really want fractions, so rewrite the denominator as a product of two numbers such that cancellation of common factors does not result in fraction. And then we just cancel it. In fraction. Okay. So I could write 6 as, so let me read again. Rewrite the denominator as a product of two numbers such that cancellation of common factors does not result in fractions. Now I'm going to look at my number 1 again. How do I rewrite 6 as a product of two numbers? 6 is what? 1 times 6 or 2 times 3. So which one do you think you'll use? Are we going to use 1 times 6 or 2 times 3? 6 is what? 2 times 3? All right, so 2 here and 3 here. So divide 6x plus 10 by 2. So this will be what? 3x plus 5. Divide 6x minus 3 by 3. So this is 2x minus 1. Okay, so we are done. So if you multiply 3x plus 5 times 2x minus 1, we will get 6x squared plus 7x minus 5. You could check, right? If you multiply, is it true? 6x squared plus 10x minus 3x, so plus 7x minus 5. Yeah? Have you seen this before? Yeah. So if you haven't seen it, you could learn it. I think this is easier than trial and error. Well, if we do trial and error, it's easy sometimes. However, well, when I tried maybe 3, 4, 5 times, it doesn't work, then I stop, right? But this one, you don't need to do trial and error. Yeah. Where is the trial and error? There's no trial and error here. Okay. So you can use it as long as the expression is factorable. We could use the AC method. Okay. Do you want to try to do number 2? Let's do it together, and I give you 3 and 4, and then you could do 3 and 4 on your own. So number 2. All right. Set up. How do we set it up? Do I have common factor that I have to factor out? No. So how do we set up now?
8x over
8. 8x divided by 8. Yes. Okay. Good. So now we have to find two numbers such that their product is equal to, remember, this is not C, this is what? AC. So what is AC? Negative 120? Yes. So the product is AC. So if you want to write a note to remind you, this is AC. AC. So that's why it's called the AC method. So it reminds you it's the AC method. Okay. So it's A times C. What is the sum? Negative 14. Okay. So this number is pretty big. So you might have to do, you might have to find a few numbers, right? So how do I have 120 and product 120 and sum is 14? So you probably need to do a few numbers. So 1 and 120, well, it's too far. It wouldn't even work, right? How about 2 and 60? Do you think it will work? No, too far. 3 and what? 40? Would it work? What about 4 and 30? No, but it's getting closer. So what about 5 and what is 120 divided by 5? Huh? Yeah, 24. How about 5 and 24? No. What about 6 and 20? Do you think this works? Okay, then let's try. So 20 and 6. Now I have to adjust my signs. Negative 20. So let's see. If I multiply, this is negative 120. If I add, this is negative 14. Okay, so these are the two numbers that we are looking for. Right? Okay, so minus 20 plus 6. All right. Minus 20 plus 6. Are we done?
No.
No. What am I supposed to do? Break up the 8. Okay, so how do I rewrite my 8? 4 times 2. Oh, where is my 4 and where is my 2? 4 here and 2 here? Okay. So 8x minus 20 divided by 4. 2x minus 5. Okay. So we're dividing 8x minus 20 divided by 4. What about 8x plus 6 divided by 2? 4x plus 3. So what do you think? This is doable? Okay. So if you want to use the trial and error method, it's fine. So as long as you can factor, it actually doesn't matter what method you use. Yeah. So if you feel, I'd rather use trial and error method, as long as you're sure you can do it, no problem. Yes? Okay. So let me give you 2 more numbers, and then you could try it out. All right? So number 3, let me find it first. Oh, so this is from my intermediate algebra book. Let me see. Library, elections, Bissinger. What chapter is this? 5, right? 5.3. Okay, yes, 5.3. Okay. Let me see. 5.3. All right. Questions so far? Are we okay? Yep. All right. So try this. Number 3. Okay, so 8t squared minus or plus 9 minus 18t. We also have, for example, number 4, 28x squared plus 38x minus 6. So we might have to factor out, organize it, or take out the common factor. We may, okay? Then we also have number 5, negative 12x squared minus 28x plus 24. And then number 6, 6x cubed plus 21x squared plus 15x. All right. So what do you want to do with number 3 first? You have to arrange them, right? You have to rewrite it so that the terms go from the higher to the lowest degrees. Yeah. All right. Let me see. Where's my attendance? Oh, actually. So Renee is here. Jose? Ayon? Okay. So please come on time. Okay. Jocelyn's here. Elizabeth's here. Maritza is here. Ashley is absent. Jesse's here. Alexander is here. Roger. Okay. Josue Garcia here. Natalie. Okay. Jace is here. Gerard here. Sandra, please come on time, Sandra. Andy is here. Edgardo. Where's Edgardo? Not here? Valentine's here. Maria here. Cicely, please come on time, Cicely. Joshua. Okay. Fernando. Brittany here. Diana. Jacob. All right. Andrew. Okay. Jennifer's here. Sonia. Okay. Benito's here. I have to talk to you, Benito. Okay. Shiyun's not here. Jose is here. Jack. Yes. Chow Yi here. Alex. Alfredo. Alfredo Nino. Not here. Yanli here. Jose Rios. Excellent. Kevin. Nicholas here. Sophia here. Isabel here. Okay. Did I call everybody? What's your name? Kevin Garcia. Okay, so I'll talk to you after class also. Yeah. All right, good. So let's do number 3 and 4. And then 5 and 6, I'm just going to give you the answers, and then I'll let you work on it. Yeah? So number 3, what do you think we should do? Yes, minus 18p plus 9. So we will divide it first, right? Okay. And set up. How do we set it up? 80 divided by 8. All right. And product. What's the product equals to? 72. Good. How do I get 72? Yes, AC. 8 times 9. Sum. What's the sum? Negative 18. Okay. So what are the two numbers? Do I have any? So 1 times 72 is too far, right? 2 times 6? 2 times 36, too far. 3 times what? What is 72 divided by 3? 24? 2, 4. What about 4? Would 4 work? 4 times 18. Does it work? No. Okay. What else then? 6 times. Does it work? Okay. So 6 times 12. So 6, 12. Adjust the sign. Negative to negative. Yes. Minus 6, minus 12. All right. Now split up the 8. 8 times 1, or 4 times 2, or 2 times 4, or what? So 2 times 4. All right. So 80 minus 6 divided by 2. Yes. And the other one? All right. Easy? Okay. Good. Yeah. Can I clarify anything? Because this is the only time I will teach it, and then afterwards I will assume you know. No, are we okay? I usually just put wherever, because if I put the 4 here, it doesn't actually matter, but if I put the 4 here, this is what you'll do. When you divide 80 divided by 4, you get 2. 6 divided by 4, you have a fraction. So that's why I'm putting my 2 here and my 4 here, because it's easier for me to see, right? Yeah, but you could actually put it anywhere, because 2 times 4 is the same as 4 times 2. It's just that if I put 2 here under 80 minus 6, it's a lot easier. That's all. Yeah? Okay, good. Now, what do we do with number 4? Do we have a greatest common factor? 2, so we factor it out first. So 2 times, what is this? 14x squared plus 19x minus 3. Is that right? Okay. So what do I do with my 2? Well, we just copy it. That's my greatest common factor. Okay, so how is the setup look like? 14x, yes, 14x divided by 14. So I'm not touching the 2, okay? So I'm not touching the 2. The 2 stays outside. All right, now what 2 numbers do the product has to be what? Negative 42? Yeah, so 14 times negative 3, that is negative 42. The sum? 19. Okay, so what are the 2 numbers? Yes, 21 and 2. Yes, so which one's negative? Negative 2? Okay. Yeah. I'm going to put in the negative 2 here and plus 21 here. And then I'm going to split up my 14. 14 is
17.
Yeah. So I'm going to put the 2 here because it's easier for me. And then 7 here. So the 2, and what do I have here? 7x minus 1 times 2x plus 3. Yeah, finish. Here you guys try number 5. And number 6. So I'm just going to wait. And then at the end, you'll tell me what the answers are. So it doesn't matter what method you use, right? So try number 5 and 6. So for number 5, what am I supposed to do first? Factor out, yes. So for number 5, I'm going to factor out negative 4 first. So Valentine, are you done? Can we try it? Okay. Yes, Josh.
Sure, that you can maybe do a description against a negative 8, or could we just use up the meaning inside?
Oh, we always factor out the negative leading coefficient, right? So if it has a negative, we always factor it out because it's really hard. Even if you have something like this, negative x squared plus 4x plus 5. Here we also factor out the negative. So even though there is no number outside, we always factor out the negative when we do factoring. It's a lot easier. Yeah, because for me, like this is hard, right? The product is equal to what? No, you need to factor out the negative. Yeah, so in this case, for number 5, actually you're factoring out negative 4. Yeah. Sure. All right. What was the answer to 5? Anybody finish? Minus 4, what?
X plus 3, 3x minus 2.
X plus 3, 3x minus 2? Okay. Did you guys get the same thing? Yeah, okay. What about number 6? Factor out 3x, right? And then you're left with?
X plus 5, X plus 1.
X plus 5, X plus 1. Okay. Did everybody get it? So I'm not going to work on these. Yeah, you should try it. All right, so let's move on. So I'd like you to finish, and then did everybody else get these answers for number 6? Yeah? Okay, so if you haven't finished, please try these today. Yeah, so you remember. But this is what the answers are. Okay, good. So let's move on. C. Oh, we're doing factor, oh no, B2. So this is B1. So B2 is factoring special product. So B2 is factoring special product. Special product. All right. Factoring special product. Okay. Alright. So we have, what do we have here? So number 1, I think you guys know this. A squared minus B squared. No, we're factoring. What is it? That's right. Good. A squared plus B squared. What?
Equals C squared.
No, this is not factorable. Yes. This is not factorable. Yeah. Actually, you've learned this. This is no, A plus BI times A minus BI, right? If this is complex. But this is not a real number, that's why we say it is not factorable. But actually in complex numbers, it is. Yeah. What about A cubed plus B cubed? And A cubed minus B cubed? A plus B times?
A squared plus 2AB.
No, this is just minus AB plus B squared. Yeah. So it's not even 2AB, it's just AB, because otherwise you could factor, if you have 2AB here, then you could factor more, right? But you can't. This is usually not factorable, so we do not have 2AB, we just have AB. And if this is plus, this is plus, and this is minus. If this is minus, then you'll see this will be minus B times, yeah. Yeah. Do you remember this? Yeah, this is in Math 125 also. Yeah, factoring cubes. Okay, so let's just do for the cube, right? Or a little bit. What about? Okay, I actually don't want to do it. I think you guys remember, right? So I don't want to say too much about it. So the third one, this is what we use in calculus. Factoring expression. Otherwise, I do too much review and then I don't have time to finish with fractional exponents. Exponents. Let's see. So we use this in calculus a lot. So it looks like this. Suppose I have x squared plus 1 raised to the half plus 2 times x squared plus 1 raised to the negative half. Got it? And number 2, we have 2x to the 1/3 x minus 2 raised to the 2/3 minus 5x to the 4/3 x minus 2 raised to the negative 1/3. Alright. So this is used in calculus. So in calculus, you see this, and then they expect you to know, right? So I was just using this. This is the symbol that this is from calculus. Or I could just use the integral. So if you see the integral symbol, it means it's used in calculus a lot. Yeah. So look at these. How do you think you'll factor out? Do these two terms have common term? So suppose I have 4x squared yz plus 3xy squared z. How would you factor out? What would you do here? Are there any common factors? X, y, z? Okay. And then you are left with what?
4x plus 3y.
Okay, good. Now, let's go back here. This is the same idea, it's just that it's a little bit different, right? But it's actually the same idea. Do these two terms have common term? X squared plus 1. Okay. That's right. And what exponent do I choose? What exponent do you choose here? Oops, I was going to do this. What exponent do you choose here? The smaller or the larger? The smaller. So I need to choose the smaller exponent, which is -12. That's right. All right. Good. Now, I factored out x squared plus 1 raised to the -12. Okay, so what am I left with? X squared plus 1, what? To the what? To the first power. So should I write the first power, or you guys know it's nothing? So when I factor out -12, then I have x squared plus 1 raised to the first power, right? What about from the second one? What am I left with? Plus 2. So this is x squared plus 1 raised to the -12 times x squared plus 3. How do I get the x squared plus 1 to the first power here? Does everybody know why this is x squared plus 1? This is actually x squared plus 1 to the first power. It's just that I don't write it. Yeah. Why? Because when you multiply x squared plus 1 raised to the -12, what do you do to the exponent? You add them, so you have half. Yeah. So if we factor out -12, then you have a 1 here, which I don't write. This is x squared plus 1 to the first power. All right? Okay. So how do you think about it? So actually this power right here is half minus -12. So that's why I get a 1 here. So here, the power that is left here, how do you get the power 1 here? 2 minus 1. So same thing here. How do I get the first power here? How do I get the first power here? X squared plus 1 to the first power and then plus 2. Well, this one, I got these from half, right, minus whatever you factor out. So this one comes from half minus -12. So it's just the same here. I got these from 2 minus 1. So the x is 2, but you factor out 1. So you have 2 minus 1. Here, the x is half, and you take out -12. So 1 minus -12. Does that make sense? So it's just the numbers that are fractions, but should be the same method. Okay, now let's do number 2. Okay. What's the common factor? The x is common? How about the 2? No, right? How about the x? Is it common? Yes, so x. So I'm going to factor out the smaller exponent. Which one is smaller? No, 1/3 and 4/3. Which one is smaller? 1/3. Good. Okay. Now, what about x minus 2? Are these two common? Yes. So I'm going to factor out x minus 2. What exponent do I use? The smaller one, which is -1/3. That's right. So I'm using the smaller exponent. When we factor, we always factor out the smaller exponent. Right? Okay, so now I already take out my common factor. Now let's see, what am I left with? So from the first term, I am left with 2. Okay. How about the x? Well, I factor out x to the 1/3. How about x minus 2? What is the power that I should put here? 1. How do I get 1? 2/3 minus negative 1/3. Yes. Oh. So this is to the first power. So if you want to write down the scratch here, so 2 times x minus 2. How do I get 1 here? This is 2/3 minus negative 1/3. Okay? That's from your first term. What about from your second term? Minus 5. What about the x? X to the
1.
You factor out 1/3, and you originally have 4/3. Yes, so x to the 4/3 minus 1/3, right? Because you factor out 1/3, you originally have 4/3. Is that right? Okay. What about x minus 2 to the negative 1/3? Oh, you factor it out already. Okay, so my expressions become x to the 1/3, x minus 2 to the negative 1/3, and what was the last one? So 2x minus 5x, that is minus 3x minus 4. All right. Okay. So you could leave it like this. Usually we take out the negative here. Or you can factor out the negative. So it gives us negative x to the 1/3 x minus 2 to the negative 1/3, and then x plus 4. 3x plus 4, I'm sorry. So we factor out the negative from these negatives. All right. Okay, why don't you do 2 more problems? How about that? Should I use a different page? Yeah, right? Okay, don't put it here. Okay. Are we okay so far? Questions? No, we're good? Okay. So next page. Yeah, number 3. What about if we have x squared plus 3 to the negative 1/3. Oh, this is almost the same. Minus 2/3 x squared times x squared plus 3 to the negative 4/3. Okay. And then last one. Oh, let me see. Let's see from the book. By the way, did everybody turn in the homework? If not, remember to turn it in. It's in the front. Some of you came late, right? Okay, so let's see. By the way, did everybody have the book? At least online? Yeah. You could search for it. Yeah. One, 1.3. Okay. Let's see what else. Okay, let's just do this one. Oh, actually, these are from the book. The harder one. Okay. All right. So, what would you do here? Yes, x squared plus 3 raised to the negative 1/3. Okay. So, when you take this out, what are you?
Wouldn't it be negative 4/3?
Oh, negative 1/3. Yes, you're right. You are right. So we choose the smaller one. Yes. And what are we left with? X squared plus 3 raised to the first power. To the first power, so we don't write the first power, right? Yes. How about the next one? Minus 2/3 x squared. That's it? Okay. So this is x squared plus 3 raised to the negative 4/3. Okay. And what are we left with? What is x squared minus 2/3 x squared? 1/3 x squared plus 3. Alright, finish. Alright. Now, questions? No? Yes.
Can you show me again how you got the x plus 3?
Yeah, this is negative 1/3. So the exponent here, right? So the exponent here is 1, and I got these from negative 1/3 minus negative 4/3. So whatever the original one minus whatever we factor out. Yeah, so the exponent here is the original exponent minus whatever we factor out, right? Okay. So far so good? Yeah? Okay, so it's 8:50, so I guess we have to be done. So there are some factoring that I'd like you to do. Oh, I didn't tell you what numbers you should work on, right, for 1.3? Okay, let me see. Let me open this. My previous syllabus. I forgot also. Hold on. Elec. Maybe let me stop the recording first, and then I'll show you what it is. Okay, so I'm gonna stop the recording now. I'm done with 1.3. Yeah, let me stop it, and then I'll show you what the number it is. So we're done with 1.3 algebraic expressions.